Discussed previously in our lectures, what happens, we have discussed how the crude oil has been taken, and after that crude oil how we have processed it by the primary or the physical separation processes, that is our distillation or fractionation, that we have done in by which unit, by the atmospheric distillation unit and vacuum distillation unit. And what we have seen there, in case of the vacuum distillation unit, our major product received is the vacuum gas oil, that we need further processing for deriving our useful cuts. So how we can do it? We can do it by a process called the fluidized catalytic cracking. Now first we have to understand what does this name signifies. If we first take the word cracking. Now what does the cracking means? Cracking means if we take a very heavy compound, heavy hydrocarbon, if we break it into smaller hydrocarbons, that is known as the cracking. Cracking means what? We have to break. Crack means if some break has been there. So from there the word cracking has been derived. So cracking means in refinery we will break a very higher chain hydrocarbon to a lower chain hydrocarbon. So this is the cracking word signifies. Now the second word, this word is what? Catalytic. Catalytic means that cracking has been taking place in what? Cracking has been taking place in presence of catalyst. That's why we term it as the catalytic cracking. Cracking can be of other types also. Thermal cracking is also there. There we provide very high temperature for cracking the higher hydrocarbons to lower hydrocarbons. But here we have mentioned it as the catalytic cracking. That means cracking is being taking place in presence of suitable catalyst. That's why catalytic cracking. Now the another word, this is the fluidized catalytic cracking. What do we understand by the fluidized condition? In fluid mechanics, you have studied that what is the static, that is the fixed one, and what is the fluidized bed. Suppose here if we see that one bed is there, here we have taken some catalyst, and these catalysts are present in a very fixed condition. That means they will not change their location to a vary. So whenever we will pass some gas, they will pass through these perforations. Clear? But the bed of the catalyst will remain the fixed. That is known as the fixed catalyst bed. Clear? But here we will not study the fixed one. We will consider the fluidized catalytic cracking. That means what is the fluidized condition? Suppose if we increase the velocity of these gases, whatever velocity we are providing for the gas, if it increases beyond a particular limit, what will happen? This fixed bed will be disturbed, and then what will happen? This catalyst will start the movement within a particular space, and that condition is known as the fluidized. I think now it is clear what is the difference between the fixed bed and the fluidized catalytic bed. In fixed bed, catalyst will be deposited and fixed in a particular bed. Clear? Whenever we will provide the gas flow, gas will flow through these perforations and ultimately it will go up. But in case of fluidized condition, if that velocity of the gas is being maintained at a very high condition, then what will happen? It will ultimately disturb the bed of the catalyst, and ultimately the catalyst will be in a moving condition. That is called as the fluidized condition. So now in catalytic cracking, what we have done, our feed will be here vacuum gas oil, that is which is derived from the vacuum distillation unit. After heating, what we will do? We will provide it to a column. This small diameter vertical column is known as the riser, and the total reaction will take place within this riser only. But there is a misnomer. What is the misnomer? Here you can see we are saying this is called as the reactor. We generally know what the reaction takes place within the reactor, but it is a misnomer here that reaction is taking place within this riser. And in case of the reactor, what happens there? Mainly the separation of catalyst from the product takes place. So we need to understand that there is a misnomer here. In case of the reactor, no reaction will take place, only the separation of catalyst with the product will be taking place, but the main reaction will take place within this riser column. So we will give this, we will feed this raw vacuum gas well from the bottom of this column, and there are the several nozzle styles attached from the in the pipe. From different direction nozzles are there. These nozzles, they are in very high pressure, they discharge this feed oil. So what will happen, whenever it will come in contact with the, from here the catalyst, heated catalyst will be provided. So whenever it will, the feed will come in contact with the heated catalyst, it will get dispersed into the very reaction will take place, and because of the nozzle spray, the feed will be provided in a very small droplets. The oil will be converted into small oil droplets, and that oil droplets will come in contact with the heated catalyst and the reaction will take place. There the vacuum gas oil will be converted through the cracking into some useful cuts, that is the useful products, the smaller hydrocarbons. And all these things, whatever vapor will be produced, whatever product will be produced, they will ultimately go in the upward direction through this riser. So in the total riser, in the fluidized condition, the reaction will take place with the feed and the heated catalyst. So our reaction is completed within riser. Basically in industry you can see this riser is a very long tube, around 5 meter to 10 meter length. So after the reaction has been completed here, in this reactor, what will happen in this reactor? First the catalyst stripping will be done, and ultimately it will be separated in this reactor through cyclone separator. All of you have seen the operation of cyclone operator in fluid mechanics subject. What happens there? Within the cyclone, in the circumference of cyclone, all these particles and the products will be rotating. Ultimately what will happen, because of the centrifugal force and gravitational force, catalyst particle will drop to the bottom, and the spent catalyst will be collected through this pipe. Here through this chamber we will collect our spent catalyst, and the product which will be remaining there, that product we will be collected to the different fractionating column for the further separation. Now happen, there is a term is spent catalyst. Why we are using this word spent catalyst? What happens during the reaction, whenever the catalyst has participated in the cracking reaction, the active sites of the catalyst has been blocked by the coke after the cracking reaction. So what happens, if this is the surface of the, these are the active sites of the catalyst, what will happen? These active sites has been deposited by the coke. So all these active sites has been blocked. So we cannot use such type of catalyst as it is. We have to first regenerate it, then only we can further use it for the second cycle. So as all the active sites, majority of the active sites are already blocked with the coke material, that's why we called it as the spent catalyst. Now our next motto is what? We have to regenerate this catalyst for the second cycle of operation. That we will do in this regenerator column. So this is called as a regenerator, because in this column what we will do, we will, in this part we will regenerate our spent catalyst so that we can further use it for the second cycle. So how we can regenerate this spent catalyst? There what will happen, we will provide the combustion air through this regenerator, and already spent catalyst has been collected here. So whenever this air will come in contact with the spent catalyst, what will happen? This coke deposited on the catalyst will react with the oxygen present in the air, and ultimately what will happen? The reaction will take place, and also we know whenever the carbon will react with the oxygen, what it will give? Either it will give the carbon dioxide or it will give the carbon monoxide, depending on the condition of the air, means how much air we are providing, whether excess or the limited or normal sufficient air. So depending on this, what will happen, the carbon will react with the oxygen and ultimately carbon dioxide and carbon monoxide will be formed. And as we know, these reactions are highly exothermic in reaction. Exothermic means what? Huge amount of heat will be liberated in such cases. So what will happen? Those deposited coke will be ultimately converted to CO and CO2 and will be delivered from the top as a flue gas. Clear? And now the catalyst which has been deactivated, now because of this reaction their active sites are now available to us again. So we can now term it as the regenerated catalyst. And another important thing is here, as we have seen, these reactions are what? These reactions are all exothermic reactions. Exothermic reactions means what? Exothermic means we will get huge amount of heat we will get from here. So because of that heat, our catalyst will be very much heated, and that heated catalyst we will use for the second cycle of operation in the catalytic cracking. So what here we can see in the cracking, this cracking reaction is endothermic. Endothermic means we have to provide the energy from outside. And in the regenerator, the exothermic reactions are being done. So in exothermic, huge amount of heat is released. That heat we will use in case of the cracking. So because of this, what we consider the fluidized catalytic cracking as a one of the most energy efficient unit of the petroleum refinery, because whatever the energy is being required in the cracking portion, that has been provided by the regeneration of catalyst, because one reaction is endothermic cracking reaction and regeneration of catalyst is the exothermic. So the energy demand for one section will be provided from the regeneration section. That's why we can conclude it as that this fluidized catalytic cracking is a very energy efficient section of the petroleum refinery. So from here, whatever vacuum gas oil we have taken, that can be processed and that can be broken to the very useful cuts for our day-to-day life, that is the gasoline, light gas oil, heavy gas oil, and some gases also, that means the methane, ethane, propane, all these gases also we can get from the further fractionation. So this is the today's lecture, and thank you.